Welcome to the Powerhouse Podcast, Episode 5, where we bring to you the powerhouses in the mitochondrial world. I am your host, Brian Harman, President and CEO of UMDF, and I'm joined by my co-host, Dr. Phil Yeske. Phil, good to see you.
Hey, Brian, good to see you too.
Well, I hope you're caffeinated. I hope you're getting some sleep. I know it's been a busy few weeks here at UMDF.
Oh, yes. Very, very busy time. But, it's all exciting stuff and really thrilled to be a part of it.
Well, of course, our world-class symposium, so much great content to bring to the community, and more importantly, wonderful networking opportunities for our families. So I'm so glad that folks get to experience that. And one of the things that's shared around this time, too, is an initiative that you and I have been talking about for quite some time over the past several weeks, and that's our Mito Share initiative. I thought it'd be good just to share a little bit about that.
Yeah, no, we're making great progress. We're really closing in the sort of the finishing touches, where you put the border around the edges and just tidy a few things up, dot I's, cross T's, and we should be launching this worldwide patient registry very soon. I would say a July timeframe, Brian, and I'm really excited to get out there. I hope the community really embraces this. We've tried to create something that is as much a valuable tool for them from a support perspective as it is a tool for engaging the patient community in research, because both of those things are very important to our mission.
So important to moving so many of our discoveries forward and characterizing our community in a way that we can advance research, but also just provide a really great resource and tools for our patient families as well. And of course, none of that can happen without strong fundraising support. And we're on the heels of some really great results of our Spring Energy for Life events. Our friends in Pittsburgh and St. Louis and San Francisco have all had their events. It's good to be back together. In some ways, we're still doing some virtual events. We have some folks who are able to get together here and there, but we're hopeful to be together again at our EFLs in the future here. And again, a shout out to our friends at Zogenix, our national walk partner, who really helped make this happen. And speaking of our donor community, just in general, came together really big this spring for us as we're celebrating our 25th anniversary, Phil. And if there's ever a time to support UMDF, I have to think it's during our 25th.
Yeah, I think we're so fortunate, right, to have a donor base that, many of these families have been with UMDF for a very long time. And they see the value we're delivering, the emphasis we place on mission delivery. Without our donors, we have nothing, right, to move forward. So this is a perfect time, right, to kind of double down, reinforce what's important to all of us. And that's a strong UMDF means a strong mitochondrial disease community.
That's absolutely right. And boy, during a time when charities were really tested, a time where the world threw a curveball that charities never had dealt with before. And boy, I'm just really proud that our donor community stepped up and said, our patients, our families will continue to be a priority despite these challenges. And for that, we're most grateful, especially during our 25th anniversary celebration. And speaking of 25th anniversary, boy, I am just really excited about today's podcast as we have an opportunity to sit down with our past UMDF Vanguard Award winners. And Phil, we've talked about this before. These are the titans of research and care in mitochondrial disease.
Yeah, even in the best of times, right? It's so hard to coordinate schedules and bring people together in person, let alone virtual. So we managed to pull it off to bring together all of these Vanguard winners. These are lifetime achievement awards. And as you said, the titans, I think of them as the true pioneers of mitochondrial research, mitochondrial disease research, mitochondrial disease clinical care. And I really think our audience is going to love what they hear in this discussion.
Well, it was so great to hear some of the history, and more importantly for me, it was great to hear their hopes for the future as well too. And boy, with the bright minds that we have with these Vanguards and so many of the folks that are in our universe, the future does look bright. And without further delay, we hope you all enjoy our conversation with the UMDF Vanguard Award winners. Hello, this is Brian Harman, President and CEO of the United Mitochondrial Disease Foundation, and
We're delighted you're here with us today. I'm joined by my co-host, Science and Alliance Officer at UMDF, Dr. Phil Yeske. Phil, once again, we've got a really great slate of guests today to talk about such an important part of our history, our 25th anniversary.
Yeah, there are slates of guests, and then there are slates of guests, and these are the giants of the mitochondrial disease field. So we're really excited to hear the conversation as it unfolds.
Well, we call our giants at the UMDF our Vanguard Award winners, and with us here today, our Vanguard Award winners. It's a UMDF award given to a mitochondrial disease researcher or clinician who has demonstrated exceptional work in advancing mitochondrial medicine field. And Phil, this really is, we kind of call this our Lifetime Achievement Award. These are this is the Mount Rushmore of mitochondrial medicine.
Absolutely. The contributions that these gentlemen have made to mitochondrial disease, mitochondrial research, cannot really be overstated. So we're really fortunate to be able to pull them all together. They're still all very busy and to join us today.
Well, without further ado, I'm delighted to welcome in our guests today, starting with our 2014 Vanguard Award recipient, Dr. Chuck Hopple from Case Western Reserve University. Dr. Hopple, we're glad to have you with us today. Joining us as well is Dr. Doug Wallace, our 2015 award winner from the Children's Hospital of Philadelphia. Dr. Wallace, welcome.
Thank you very much. Great to be here.
From Rady Children's Hospital, UC San Diego School of Medicine, our 2016 award winner, Dr. Richard Haas.
Hello and good morning. It's a great opportunity to chat.
Thanks for being with us. And Dr. Larry Grossman joins us. He's the 2018 award winner from Wayne State University. Dr. Grossman, thanks for being with us.
Hello, thank you for inviting me.
And Dr. Bruce Cohen, our 2019 award winner from Akron Children's Hospital. Bruce, a pleasure to have you with us here today.
Thank you. I'm humbled.
And unable to join us, but here with a very special message, is our inaugural Vanguard Award winner, Dr. Salvatore Damaro of Columbia University.
Cari colleghi, I'm happy to be with you today, late in my retirement, but I hope you will have a happy and efficient work with your UMDF. My UMDF is my old home, of course, and I feel at home with you again. Thank you, and all the best.
Well, thank you so much, Dr. Damaro, for your kind words. It was really great to see Billy on video. He's the very first winner of this prize. And Bruce, just to get a conversation going here, I thought maybe you could comment on the contributions Dr. Damaro has made to the field of mitochondrial medicine.
I'd love to. I got interested in mitochondria. I don't think we were using the word mitochondrial disease back in 1983 when I met a patient who had congenital lactic acidosis. She had Pearson syndrome. But as I was leaving my internship and residency at Children's Hospital Philadelphia and heading off to Columbia Presbyterian in New York, my mentors in Philadelphia said, "Oh, you're going to a great place. Dr. Damaro, Dr. DeVivo at Columbia are people very interested in mitochondrial disease." So I met Dr. Damaro back in 1984. I don't think he'd remember me. I was the kid sitting in the back of the room. I wasn't even 30 yet. And there was this soft-spoken, kind, compassionate man who everyone listened to. He carried a big stick. And he was obviously back then, and we now know one of the people that brought mitochondrial disease, mitochondrial medicine into this century. And his contributions from describing the clinical aspects of the disease to the genetic aspects of the disease are just amazing. And at the time I was a student the relationship grew over the years. One of the most delightful 2 hours I spent was at a booth with my wife and Dr. Tomorrow, sitting there, starting initially talking about mitochondrial disease. And then he gave my wife his recipe for how to make risotto. And that's the recipe she uses to this day. He can cook a mean risotto. The trick is lemon juice.
We'll put that in the show notes. Appreciate that. Wonderful.
Wasn't Billy in
recollection.
Philadelphia before
I'm sorry,
he went
Dr.
to
Huppel.
New York?
Correct. He got his start at Hospital University of Pennsylvania, and I think moved to New York when Bud Rowland became chairman at New York.
Yeah, yeah.
Yes. I also met him in the 80s because at the time we had identified cytochrome oxidase genes from cow, where you can get a lot of tissue, and he wanted to use those to isolate the human ones to look for disease genes. What I especially remember about my first meeting in his office, where I stopped on the way to the airport to return to Detroit, was that I had 2 suitcases, one of which was full of bagels, which I bring back to the Midwest when I'm in New York. And they were rather pungent, garlic and onion bagels. And as we were talking, I could see that he was distracted, and he kept looking at my suitcase and finally said, "What do you have in there?"
I think this points to something very fundamental. You can take a New Yorker out of New York, but you can't take New York out of a New Yorker. That's for sure.
Yes.
Well, I'll tell you what I didn't expect in the first few minutes of our conversation today was a recipe on risotto and interstate bagel transfer as well. But this is great. I'm so excited to hear so many of the stories of the past 25 years of UMDF and the leaders in mitochondrial medicine. And I know our listeners are excited to hear about that as well, too. And to that end, Bruce, I'm going to stick with you here for a minute. When we talk about putting mitochondrial disease on the map, as you referenced with Dr. Tomorrow, certainly a big pin on that map is Mr. Chuck Mohan, who 25 years ago had the inspiration and vision to launch the UMDF. And I know you were a big part of that as well, too. So I was hoping you could take us back a little bit on the genesis of UMDF and Chuck's leadership as a patient advocate to the early beginnings of UMDF with Chuck.
Sure, I'd love to. On April 15th, 1997, Chuck Hoppel, Doug Kerr, and I took a plane ride to Philadelphia. And that is the day that the Philadelphia conference, which was, arguably, I've lost count if we're counting that the first or second UMDF conference took place. And that was the second. The first was in 1995 in Indianapolis. And I remember meeting Chuck that evening, sitting around a table in a conference room at the Doubletree Hotel in Philadelphia. Chuck telling the story that in Indianapolis, there were a whole bunch of booths set up by the individual mitochondrial organizations. There was the Cox Foundation, the Lee Syndrome Foundation called ABCD, I think adolescents and babies with carnitine deficiency, numerous foundations, and everyone had their pamphlets. And Chuck could call the meeting of all these little foundations together, tore up the Cox Foundation literature and threw it on the table and said, let's all tear up what we have made and join together and unite and form something bigger. That was a story that, Chuck told, a number of times, and as to the birth of the United Mitochondrial Disease Foundation.
And here we are today with the opportunity to speak with all of you about achievements over the past 25 years, your experiences, your inspiration. And again, we maintain our inspiration because of leaders like Chuck. And we might get into that a little bit more later here as well, too. But speaking of inspiration, it's a question I have for all of you. I know it's really important to us to understand, and I'm certain our patient families and our listeners would love to hear about what inspired you to get into this field. And Dr. Wallace, I'm going to start with you. I'm going to ask, what inspired you to take this path?
Wow, thank you. So when I got out of the service in 1970, I was very interested in the role of science in medicine, and had a physics background. So I knew that energy was very important in making matter and mass move. And I learned that almost everything in medicine was about anatomy. And it occurred to me, gee, maybe there was an energetic component to that. And it was already well known that the mitochondria generated 90% of the energy, and just recently that it had its own DNA. So as a young graduate student, I proposed, well, maybe there are mitochondrial DNA diseases that cause energy disease. Of course, that met with not a little bit of consternation. But I was fortunate enough to have a advisor, Jerry Eisenstadt, who was willing to put me in a corner and leave me alone, and started working on that. And ultimately, we developed a mutant in the mitochondrial DNA, and then developed cybrid transfer and showed that it was maternally cytoplasmically inherited. And then we continued to try and work this up, ultimately to look at mitochondrial DNA as a mutation in disease. I must say, at the same time, my friend Larry Grossman was working on mitochondrial DNA in rats at the time, and he had just come out of Vinograd's lab where they had actually first isolated the mitochondrial DNA. And I had the real privilege of knowing a number of the leaders in the medicine field, Billy DeMauro, John Morgan Hughes. Much later, Anita Harding joined us. And then in about 1981, the sequence of the mitochondrial DNA came out of Cambridge. And that then really allowed us to begin to build a structure around changes in the mitochondrial DNA that give rise to disease. But I will say that it's been a challenge, and the contributions of UMDF and Chuck Mohan have been enormously important, as well as all of the people here, because there was a tremendous resistance throughout all that period that mitochondria was important in mainstream medicine. I was told repeatedly, how can you study mitochondrial disease when they don't exist? If you study mitochondrial disease, you'll ruin your career. I was once told mitochondria had nothing to do with medicine. And the people on this call were the people that had the strength to stand up against the naysayers and really bring to all of our colleagues and our families at least the beginnings of a diagnosis and hopefully therapies. And I want you all to know that we continue to be committed, at least I will until I die, to find a cure. That's what we really want to do.
We certainly feel it. Thank you for sharing it. Certainly highlighting some of the hurdles that have been that we've faced as a disease community over the past years. And I want to dive into that a little bit later as well too, to kind of understand how we've overcome those and what we're going to have to continue to do. So we're going to come back to that. Dr. Grossman, Dr. Wallace was highlighted the parallel tracks that you all were taking, and I was hoping you might share a little bit about some of your own inspiration of how you got into this field.
Yes. So I started, in basic research, and in fact, I was involved in one of the early demonstrations that mitochondrial DNA actually exists, which was not a given at one time. And one of the remarkable things that I've witnessed is the degree to which actual mutations in both mitochondrial and nuclear DNA have been associated with diseases. When I first became involved with the United Mitochondrial Disease Foundation, barely a quarter of diseases actually had a genetic basis that was known, whereas now it's more than half. And of course, knowing the identity of a gene that's involved doesn't help anyone per se, but it's a starting point for trying to improve the presentation of a patient by investigating what goes wrong. Uh, my my knowledge of the patient side, not being a clinician, came through the United Mitochondrial Disease Foundation, because the meetings which I started attending, early, involved patients and patient families, as well as basic researchers and clinicians, and having lunch with a family and seeing the problems they go through just to do everyday things has really been one of the inspirations. I remember talking with a woman who was wheelchair bound at the time, but said that even as a young girl, when she and her friends would ring a bell to trick or treat for Halloween, she was always the slowest runner when they all ran away, and so suspected that something was wrong. And that highlights the progressive nature of mitochondrial disease. So we've, gotten to the point in my own lab where we can work on a gene that causes disease with the help of my old friend Doug Wallace, and actually try to modify the harms done to cells and the people in whom those cells reside.
There's
So
always a
this has
person
been
behind
an
it.
inspiration to see the whole path develop, and the UMDF is just the most integral part of it.
Well, certainly appreciate you sharing that. We feel the same way, right? There's always a patient face behind all this effort. And Dr. Cohen, I know you and I have talked so much about that in terms of your own inspiration from the patient families we serve, and thought it'd be nice for you to share a little bit about what inspired you to get into this field.
I was inspired by a single patient who presented at 8 months of life with anemia and horrible lactic acidosis. I didn't even know Richard Kelly that day, but they called him up and to help with the patient, and he and I formed a relationship after that. And I spent, again, a year and a half at his side learning about mitochondrial diseases before moving off to Columbia. So it was the patient face that got me interested. And I love the idea that this was a new field, unexplored. And I was actually told at the time that mitochondrial disease could be something I could, be a little bit interested in, but it wasn't going to be a career because there weren't any patients with mitochondrial disease. And so, little did I know, there are plenty of people with mitochondrial disease, and we just needed to identify who those people were. So it was really the patient's face that got me interested in it. And now that I sit here, some 35, close to 40 years later, still taking care of some of the patients that I identified in the early 90s, I knew I made the right decision.
Well, one of the things that continues to inspire us is hearing all of you talk about that, how meaningful it is to know the patients and their stories, and knowing that this is a team that is helping patients on this journey. And part of that team too is educating the next generation of researchers and clinicians. And Dr. Haas, I know that's a passion of yours. I know it's something that inspires you, and I'm sure there's other inspirations that you have as well. But hoping you might be able to comment on that as well.
Yes, no, obviously education is really critical. And as you know, I have the privilege of heading up the educational part of the NAMDAC, North American Mitochondrial Disease Consortium, which gives me the opportunity to work with a lot of very clever trainees who have made a big impression already on the field. So that's certainly a very important thing. But I'd like to go back again to what triggered me to get into this field. So I actually started out as an undergraduate at Cambridge with an interest in biochemistry and pharmacology, But at the time, I really didn't know anything much about mitochondria. But when I then continued with my medical training, I finished up in the UK at the Hammersmith Hospital, and came across a little boy who was at the time 4 years old with Lee's disease. And that really made a big impression on me. Actually, I have a 16mm tape of him walking and stumbling all over the place. And he, of course, also had lactic acid elevation. So that really triggered my interest in patients with mitochondrial disease. And I then went on from there to a mitochondrial lab, and the Stalinsky, part of the Stalinsky lab in Denver, and did pediatric neurology fellowship. At the same time, working with mitochondria with David Stumpf. So it was really the combination of an interest in biochemistry, coupled with seeing patients who had biochemical diseases that triggered my ongoing interest. And I think that that really is an important message, that mitochondria bring together basic biochemical activities with human disease in a rather unique way, actually. So we're continuing, of course, to discover new diseases almost on a daily basis, and unfortunately, they're not going away at all. In fact, later this morning, I'm going to see a new baby at our Awardees hospital with a mitochondrial disease that's probably going to have a severe outcome with nuclear gene mutations and high levels of lactate. And that actually was possible to diagnose because of one of the newer innovations, which is whole genome sequencing carried out in 48 hours that gave us the diagnosis in this baby. So we've come a long way, and we have a long way to go still.
Certainly, we recognize that there are new patient families who are starting that journey every day, and that's what keeps us motivated, and clearly it keeps you all inspired. And we've been talking a lot about the days before the UMDF and before some of this was defined. And Dr. Hoppel, I think it'd be great for you to share a little bit about the days of mitochondrial biology research and how you were inspired to get into mitochondrial biology research even before the UMDF was formed.
When I was a second-year resident in internal medicine, we had a research rotation a month, and I worked in the lab of Robert Bollinger, who was the chief of endocrine and metabolism. He gave me a project to isolate lymphocytes from patients and study them for their oxidative metabolism using a Warburg manometer. And the Warburg measured oxygen pressure as millimeters of mercury. So you filled the gauge with mercury and monitored it over a period of 4 to 8 hours. I had patients who had hyperthyroidism, had lymphomas, and leukemias. And so I used to go, so that my month was very productive in getting this horribly difficult to use instrument working. And then I went on clinic. So I could go to a patient's home at 6 o'clock in the morning, grab their blood, and also give them their clinic visit and their blood from the clinic visit, take that back to the hospital to get it processed, and then have my blood for getting lymphocytes to do in this instrument. And so I didn't know very much. It was clear that I became technically okay to do that, but I had no idea what the results meant. But I was intrigued by the difference between hyperthyroidism and the normal patients I used that had had a disease like a pneumonia and had recovered. And the one thing I learned was where patients are extremely willing to interact and participate in research. And it was really a great feeling during that time. So I decided I wanted to go in deeper into whatever this oxygen consumption was, and went to Western Reserve University and worked in the lab of Cecil Cooper on mitochondria. Cecil was an Albert Leninger trained biochemist, so he had a good legacy from. And anyway, I did liver mitochondria, and it was very productive, had fun. But one of the things I asked Cecil when I interviewed to go in his lab, do you use the Warburg manometer? And he says, oh, no, I have this oxygen electrode I use. And I said, okay, I'm with you. I don't think I'd have continued. I mean, Warburg won the Nobel Prize 100 years ago using that manometer. So it's not that but it was archaic.
Well, certainly talk about inspiration, is just the development of the field over these so many years. And Phil, I think it's a great direction for us to take this conversation. Just some of the differences we've talked about a few of these already in the introductions and hearing from the docs here about their own inspiration. But we talk a lot about at UMDF, this hunger for understanding, and I'm hearing you all say it too, right? The things I just picked up. Thank you so much for sharing your own inspiration about patient families. It's about learning. It's like constant hunger for understanding, and we've seen so much development. And Phil, I think we should take this conversation in this direction where we're talking about some of these big changes that have happened over the past several years.
Yeah, I think the thing I'm struck by just listening to these gentlemen talk is that they're really the entrepreneurs, right, of mitochondrial biology, mitochondrial disease. They're the risk takers. That there were no guarantees that moving in this direction were going to be professionally rewarding, personally rewarding, but they moved ahead, and we're kind of really struck by that. You hear it in each of these stories, and of course when Chuck and Larry and Doug talk about these early days, it's also a reminder that there weren't a lot of tools available. Those tools had to be developed, and that made it all the more challenging, and just speaks to the perseverance that was required to have those early successes. And without those early successes, there definitely wouldn't have been a United Mitochondrial Disease Foundation, right, around which to really rally. The mission is clear, right, to support these families, to educate, awareness, but fundamentally, it's also about trying to develop treatments and cures for mitochondrial disease. Absent that early research, at a time when clinically mitochondrial disease wasn't really understood at all or recognized, we wouldn't be where we're at today, which is a really exciting time, right? With increased clinical activity, lots of clinical trials starting. It all comes on the shoulders of those that came before us. And you hear it again from each of these, that inspired by others and the work that they did.
Well, I think it'd be great for the group. I'd love to open up to the group just to help our listeners and viewers better understand, in your view, just some of the biggest differences you've seen in the research field today versus what you were experiencing in the early days. We heard a little bit of that here, but love to open that up if there's any stories or thoughts or comments on that.
There was a book in early 1960s by Albert Leninger, who was chair of the Department of Biochemistry at Johns Hopkins. He had been at the University of Chicago before that. He's a superb writer. He has a book, Mitochondria. And there's no mention in that book about DNA, RNA, protein synthesis in the mitochondria. It was, but it was a beautifully written, very clear book. And then there's a book by Ephraim Racker, who was a biochemist at Cornell in Ithaca, who actually purified complex 5 and broke it into pieces and studied it. He has a book on bioenergetics. There is no mention in either of those books about DNA and RNA. And the controversy when RNA and DNA were proposed to be in mitochondria, the heated arguments were something to behold.
Yes, I think one way that we can look at the progress over time is that at one time the idea of a mitochondrial disease was itself a controversial uphill battle, whereas now for almost any disease one asks the question, what's the effect on mitochondria? I mean, I think it's become an integral part of thinking.
My first R01 that I submitted in 1968 was on pleoclonal and megaclonal mitochondrial in skeletal muscle. And it was approved in 1969 for funding. And my career development award on the same subject was approved for funding. And then Richard Nixon impounded the NIH budget and they had no money. And so for all of 1969 into 70, they didn't fund. I was very fortunate. My research career development award about 3 months later was funded, but the R01 was never funded. And they didn't carry him over into the next year. So it wasn't called mitochondrial disease. It was giant mitochondria and increased mitochondria in the muscle.
Dr. Wallace, maybe you could comment a little bit on just some of the key milestones you've seen over these past years and some of the big differentiators for you.
Well, clearly, the leadership of people is absolutely the most important thing. Mm-hmm. But we've already touched on that. I think the other thing that Richard mentioned is the importance of the evolution of technology. And that really has gone hand in hand with our being able to diagnose these diseases and to begin to think about therapeutics, at least from the gene therapy point of view, as Larry mentioned. One of the interesting mentions of Chuck, I also started out my bioenergetic career with the Warburg apparatus, but that Warburg apparatus maybe was much better than Chuck's, I don't know. It had a big central vat, and it had maybe 24 of these little vessels, each one tied to a little manometer. And then you put in your cells and you put in your substrate, and then you turn it on and the whole thing shook in the water bath. And it made such a clatter that people would actually leave the lab. They couldn't talk. But you could do more than one sample. So I guess we were one step above you there on Chuck.
We could do 8 samples.
Oh, yeah. Well, see,
but
there you go.
You had to calibrate the mercury on each one of those.
Oh, absolutely. I'm not saying that we didn't do it right. Yeah. But then the next thing.
Think about that mercury today.
Oh, wow. Yeah. But the other, Yellow Springs came up with the commercially available oxygen electrode, and that was absolutely a stunning advance because that. And so my first job was $20,000 a year salary, and I was given $10,000 as startup funds. And the one thing that I bought was a Yellow Springs oxygen electrode. That's what I could afford. And that really made it possible to do real quantitative and reproducible measurements. But then, the other interesting thing was in the area of molecular biology. There was no human molecular biology in the 70s. The first real change came with the development of ability to isolate mitochondrial DNA, which Larry was very involved in, but then with restriction enzymes to actually look for variation. And really fun experience that we had. I had been at Stanford at the time collecting families and transforming their blood cells with Epstein-Barr virus to make lymphoblastoid cell lines. And but all we could do is isolate the DNA and do hybridization or very complicated experiments. And then Y.W. Kahn from UCSF came and gave a lecture about looking at sickle cell anemia. And he had an enzyme HEPA1 that cut DNA. And I asked him if I could just have a little bit to cut the DNA. So we took the HEPA1 and we added it to our DNA samples from all the Stanford pedigrees. And lo and behold, the father's HEPA1 patterns never matched with the mother of the children. And the reason we could do that experiment is at the same time, before it was published, we had access to this very strange method, came out of Scotland, Edinburgh, from a fellow named Southern, nobody ever heard of. But you took Watton paper and you add this highly toxic compound to it, and then you could run your DNA on a gel and then electrophoresis it onto this derivatized paper, and whatever the compound was would bind to the DNA. And then we could hybridize with a probe I was making out of mitochondrial DNA with E. coli RNA polymerase, which we were purifying. And I was getting out of 5 millicuries, maybe a couple 100,000 counts. But then lo and behold, when we did the hybridization, there were the patterns. So that was very similar to the patterns Larry was seeing with I think at that time was rat, right?
Yeah. We're using cow a lot because you could get so much tissue from a slaughterhouse. That's why a lot of biochemistry was done in cow, even though there is no genetics or very little genetics.
So anyway, that then led to, well, gee, maybe we should sequence the mitochondrial DNA, but there was only Maximum Gilbert and Sanger sequencing, which was incredibly laborious. But I wanted to sequence the mitochondrial DNA of a pedigree, which is now known as the Murph pedigree, and Labor's. But if I was told they weren't maternal, they were X-linked. But we decided to try it anyway. It took actually 4 years because we had to clone every tack. At that point, there were tiny little tack fragments. So you'd clone them into M13 vector and then sequence a couple hundred bases. And then you had to glue that all together. And some tack fragments were almost impossible to clone. So it took us 4 years to make our first mitochondrial DNA sequence, which was for Labor's. Now, of course, you can do that, I don't know, half an hour.
I was just going to ask, educate me a bit. We talk about differentiators. I'd love to hear that.
And then later, the idea, well, there would be clearly nuclear genes that would be important. So we in the 70s, I guess that was 80s, I'm sorry, in the late 80s, we decided to clone the adenine nucleotide translocator in the ATP synthase beta subunit because they make the ATP and transport it. To clone that took 5 years because we had to make lambda vector plasmids of the whole RNA genome and then screen it with oligonucleotides we fantasized might be homologous to the proteins. And now you just go to the computer and type in the gene and out it comes. So as Richard says so brilliantly, there's this very nice paper now from Patrick Chinnery where I think they've done like 400 or some whole genome sequences of patients with mitochondrial disease. So just the difference from when Chuck mentioned the late 60s, early 70s to now is really remarkable in technology.
Richard, are there some differentiators that you point to that we haven't covered?
So again, I think that the major advance in the field has been genetics. So we often encounter patients that we think have mitochondrial disease, but you really haven't proven it until you have a genetic diagnosis. And that, as it turns out, is critical for the next phase of what we're doing, which is clinical trials, because none of the pharmaceutical companies are going to accept patients into the clinical trial unless they're completely sure that they have mitochondrial disease. And that requires genetics. This background here is at the Altman Clinical Translational Research Institute at UCSD. And we have a wonderful facility for doing clinical trials. And as Phil and Bruce well know, we're actively involved in, at the moment, 4 clinical trials in mitochondrial disease, and I'm sure there'll be more coming along. And that really is incredibly exciting after all of these years of really not being able to do very much for patients at all. To have the hope that we are going to be able to make a difference is really a crowning achievement of the field, I think, with hopefully much more to come in with genetic treatments, which will actually be curative, but we're not there yet.
Well, your clairvoyance is strong today, Dr. Haas, because that's the direction I wanted to go in next. Was talking a little about what excites us in this field. It's been really great to hear the history and the stories, and I think we're going to have to add to the show notes, Phil, and maybe to our 25th anniversary website timeline, some photos. And if we're fortunate enough to discover some videos of some of these techniques and items that we were talking about, certainly be a great education for me. But I want to take the conversation in a direction about what's exciting us in the field. Dr. Haas talked about this rise in clinical trial activity, and Phil, this is something that certainly UMDF is starting to pace with as well.
Oh, absolutely. I think back even a decade ago, right, we maybe had a single clinical trial in the space, very nascent days of drug development.
We got you on mute there, Phil.
Oh, sorry. Now we have multiple clinical trials, multiple companies, developing therapeutics. It's really an exciting time, right, for the community. And there's no question that in general, drug development is moving in a direction towards more personalized medicine, and genetics is the underpinnings of that. So a lot of what we've heard here really grows out of the work that came from these early pioneers.
So Dr. Cohen, as you look at our timeline, the early days of this organization and the parallel track the field has taken, I'd love to hear from you of what's exciting you in the field today in terms of where we're going.
So there are a few answers to that question. I do want to take us back 15 years or so, and that's talking about education. Because in the early 2000s, most clinicians, most physicians hadn't heard of mitochondrial disease. And one of the things that from my mentors, sitting in this audience right now, helped me understand mitochondrial disease. And I wanted to take that to the public. And I remember it was a hot August day in Minneapolis, August 2008. And I had just given a few talks at the universities in Minneapolis. And Ken Wallace up in Duluth, Minnesota, had invited me to give a talk in Duluth on mitochondrial disease. I think to a research unit, not to a clinical unit. And Chuck Mohan flew into Minneapolis that day. We got into a PT Cruiser, which is smaller on the inside than it is on the outside. It was not a big car, and drove up to Duluth at Kendall Wallace's invitation. And we were met by families. And so we, impromptu put together a family talk. Chuck talked for about a half an hour, and then I talked for about an hour. And we said, maybe we should take this show on the road. 40 states, several hundred lectures, and over 100 medical centers later, Chuck and I had visited over the next decade, talking about mitochondrial disease. There's so many fun stories about the times that we had, but we would go into a city and put on a talk for the families, and we'd put on some grand rounds. And that was really an unbelievable time. One of the most rewarding sessions took place in Philadelphia. My plane was 4 hours late. It was a Sunday evening presentation to a family that was supposed to start at 6. It started at 10:30. The family stuck around. We went to 1:30 in the morning. And then the next day I was, giving talks to physicians. I think I was up at St. Christopher's that time around. And Chuck was engaging with the families. He kept everyone on track, kept the organization together through some pretty rough times, and was a true inspiration to everyone, families, patients, and the medical professionals, the scientists and physicians.
I think it's such a beautifully illustrated point. As we were going through the process of honoring the history of UMDF on our 25th anniversary and collecting some assets to celebrate our 25th, well, you can't find a photo of something meaningful done with this organization in this community without Chuck Mohan in it. And to me, that was very telling in terms of the presence he had in this field. And, certainly I know Chuck would say that was strengthened and maximized because we have partners like all of you who have adopted this organization as one of their own and are committed to moving that forward. And that's what excites me as I think about the excitement of the next 25 years, or God willing, we're not here in 25 years. And we talk a lot about that. Let's put ourselves out of business as much as we can here at the UMDF. We're starting to see the meteoric rise of clinical trial activity. We're starting to see a galvanized patient base who, this was mentioned earlier, who are ready and willing to enroll in trials. And I want to hear from all of you when you think about, your early days of inspiration and, how that now translates into when you wake up today, what's keeping you motivated? What's keeping you excited? What are you seeing in the space today that is meaningful to you?
Ryan, could I expand on what Bruce said about Chuck Mohan?
Please do.
Bruce and Doug Kerr and I had the mitochondrial medicine meeting in 2001, I believe, Bruce.
2000. Yep.
2000.
It was 2000. Yep.
2000. That was my first time to meet Chuck. I joined the scientific advisory board at that time, and then the board of trustees. And under Chuck's leadership, the organization and structure of the scientific advisory board was revolutionized. The scientific review committee was revolutionized. It became similar to the American Heart Association as a voluntary health agency research review committee, and had a major impact on funding young investigators. And this was all under Chuck's leadership. It would not have happened unless he bought in and did this. So I joined. And then for years, we tried to get the board to fund a clinical fellowship for training physicians to take care of clinical patients. And that finally happened again under Chuck's leadership. And a fellowship was developed within the UMDF to fund that. And none of those things would have happened. Chuck's personal history is as heart-wrenching, as tragic as all the rest. And I have to say, I have a prejudice in that I have 2 grandsons that have mitochondrial disease. So I had been working on mitochondria for 25 years when Bruce was involved in both of those diagnoses and care. So I have a newer drive, but Chuck was the reason that the organization responded and I think really came up in the world.
So Chuck, if I could hop in here, I just want to give accolades to the UMDF itself, because I think this organization has been pretty unique, and as Larry pointed out, in bringing together the families and the scientists. And there are not very many scientific meetings that do that, certainly not as effectively as the UMDF. So I think that that's one big reason that the scientists themselves are motivated to carry on researching in this field. And I really think that the patients and their families are deriving a lot of benefit by that format. And COVID, of course, has really put a spanner in the works for all of us. And we're really looking forward to the next face-to-face meeting, which, as you all know, is going to be in Phoenix next year.
Other thoughts on what's exciting you in the field today and keeping you all motivated?
Well, I will elaborate just a bit on Richard's comment. Sometimes I've had the privilege of having meetings with the families organized by UMDF during and after the meeting. And I had one really wonderful experience with my great colleague, Marnie Falk. And we were talking to patients. And what was striking is how important inhibition of muscle motility was. In that particular discussion, the gastroenterological complications, which most people don't talk about, but can be so difficult for families. And I think that helped us realize that, we shouldn't just be looking at this disease on it's not just skeletal muscle, it's not just the brain, it's not just the heart. We need to be looking at the whole individual and all the complexities these people have to suffer with. That was actually very eye-opening for me.
Phil, I've been thinking a lot about some of the themes I've been hearing in our conversation today. I've written these down. Themes of leadership, themes of passion, this relentless pursuit, and ultimately a theme of patient-centered care.
Absolutely.
That's what this means for our patients. And I'd like to take the conversation in that direction a little bit here of bringing this all back to the patients. And it's something I'd like to ask each and every one of you before we wrap today's conversation is, what is your hope? What is your hope for not so much UMDF? We're glad that you're fans of the UMDF, but as you know, the UMDF is the patient families we serve. And I want to ask each of you what your hope is for the mitochondrial disease community. And Larry, I'm going to start with you.
Sure. Well, my hope is very simple, that there will be effective treatments for, I don't know if it'll be disease by disease, but maybe category of disease by disease. For instance, those caused by mitochondrial DNA mutations, but I think we're at the point now where we can think of therapies that would actually be effective, and we may already have some, but I think this will increase, and I think this is where we all wanted to end up, and I think it's happening. I think, and seeing it happen is really an inspiration.
Richard, your hope for the mitochondrial disease community. We might still have you on mute, Richard.
You are muted, Richard.
Sorry about that. Certainly, it is the plans that we all have for eventually a cure. But I think the other thing is that we really are hoping that we'll be able to expand access to care for our patient community, and that's something that has been slow in developing. I think there are still only a relatively small number of centers in the country and in the world where people are specializing in mitochondrial disease. And I think that what has basically held us back is the fact that there isn't yet a really proven effective treatment. And for doctors in general, one of the main triggers to really wanting to look for diseases and care for the patients is whether there's a treatment or not. And I think once we do have an effective treatment, even without it being a cure, just the first effective treatment, the medical community in general is going to take note, and things will move forward more rapidly. I certainly hope so.
We hope so too. Dr.
Yes,
Hopper.
can I add one
Oh,
thing
please.
for a moment? I think another thing that may be changing and that we expect to change even more is diagnosis. One thing I remember from meeting families at the UMDF meetings is the size of the folder, the medical folder that some of them showed me, how many doctors they had to go to before anyone could tell them what might actually be wrong. And I think what Richard has mentioned about, at least at a mitochondrial disease center, that within a few days you can get a sequence that's a diagnosis, is a really big step forward.
I have to say, though, there's also been a step backward, which is that when you're dealing with genetic results, we are often faced with what are called variants of unknown significance that don't yet be proven to cause disease. So we have lots of patients sitting out there with a probable genetic diagnosis, and what's missing is the translational part of it. And we really have lost a lot of this really important ability to do oxidative phosphorylation studies and even electron transport assays in patients to help prove that we're dealing with a functional disease problem. So that's an area that we really need to improve. And I think that, the pendulum swings back and forth, and at the moment it's swung very much in the direction of genetic diagnosis, but then we have a whole collection of patients that we're really not sure about yet.
Dr. Hopple, what is your hope for the mitochondrial disease community?
Two-phase. One is care. I think in the immediate future, to improve care and try to find pharmacological or nutritional agents that have an impact. But ultimately, I just finished reading the book, The Code Breaker by Walter Isaacson about Jennifer Doudna and RNA and CRISPR-Cas and editing the genome. And it was clear that the future is when Doug and Larry can get CRISPR-Cas inside a mitochondria to take that point mutation and restore it, or the nuclear to do the same thing. I think that is the future. And then and if we do that as germlines and it's safe, then there is no more mitochondrial disease, at least for those that we know. So I'm very, very encouraged. Dr. Doudna and her colleague, Dr. Sharpener, got the Nobel Prize just recently for their work, and I think it's a stimulus.
Exciting to hear that, and especially in the context of so much of the great historical conversation we had today, to see just the rapid change.
Can I just point out, to follow up Richard's comment about functional mitochondrial physiology? Doug Kerr and I, with Art Zinn and recently Jared Bedoyan, had a Center for Inherited Disorders of Energy Metabolism at the University Hospitals of Cleveland for 40 years. It has been canceled. So it no longer exists.
Certainly inspires us to continue all the good work that we're all trying to do together here. Right?
And I think also, a reminder, Brian, that oftentimes in science, it is 2 steps forward, 1 step back, one step forward, 2 steps back. It's never a perfect pathway that, we'd love to see of just moving from not understanding the problem to solving the problem. There are going to continue to be barriers that we face. I think what I'm really heartened by, and again, hearing these comments as we kind of go around the panel, improved diagnosis, development of treatments and cures, optimizing clinical care. That's the roadmap, right, that we established within UMDF. And we're hearing it over and over again. Like, these are the major buckets where we can focus resources and people on trying to solve these major issues within mitochondrial disease. And by working together, that's how we get to our goals.
Perfectly well put, Phil. I was going to ask you to help us weave that back into what's happening here at the UMDF. And it's partly what we do every single day is driven by that plan, because we know we have a legion of supporters and leaders out there that are doing that. And I was also going to ask you, Phil, this group here has been so generous with their time today, and it's such a privilege to be together with all of you. But I would be remiss if we didn't take this opportunity to see if there's anything else that we want to ask this group while we have them here. Phil, I think we've covered just about everything, but what might we be missing today?
Well, again, I think we heard from the research side, some of the challenges that early researchers, clinician researchers faced in having access to tools, to lab supplies, even philosophical barriers, right, of just accepting that mitochondrial biology, mitochondrial function was important to the human health condition. And then on the clinician side, I think clearly through Drs. Haas and Hoppel and Cohen, those early patients where they were really piecing together a diagnosis, absent a lot of things we take for granted today. That really gives us an idea of just how far we've come, not just in the last 25 years, but even beyond that to 40 years or half a century. It's, for me, exciting to think about that, that next 25 years and 50 years. We've heard some of the hopes and dreams from the panelists here. I think, Dr. Cohen, you're so central. I mean, you serve as an advisor now. I know every member on this panel today, this discussion has served as an advisor to UMDF, and I turn to you often for guidance and insight. But Bruce, I'd love to hear from you, as someone that really sits at the crossroads of the research, the clinical care of our patients, and therapeutic development. Capture for us your thoughts on where we're heading as a disease community.
Well, a couple things. First of all, I'd like to thank Richard Haas, because we haven't acknowledged the fact that Richard set up one of the first therapeutic trials in mitochondrial disease. I remember giving him a call back in 1992. Again, that's before any of us had email, because I had a patient with severe lactic acidosis, and you were running a dichloroacetate study, which was clearly one of the first clinical trials in the treatment of mitochondrial disease. And we got that girl out to your center. And that's a second thing. Not only were you doing clinical trials, and you're clearly central to the development of the current clinical trials, because you've been doing it the longest, I actually was able to send a patient out to a center, a mitochondrial center. I later visited that center, but you, Bob Navio, Bruce Barshop, and Dr. Nyan had put together a biochemical center, but that's a place that patients could go for intense clinical study and for comprehensive mitochondrial care. So, I don't know if that was the first center of mitochondrial health in the United States, but it certainly was at the time I believe the biggest, where you provide prolonged, consultative and hands-on care. So, Richard has developed the basics for everything that you were just talking about, Phil. In addition, education of junior people, and you've clearly taken leadership with that. Chuck, I want to thank for providing 2 decades of mentorship and getting me turned on into to oxygen electrodes and state 3 and state 4 respiration and all those things that, gosh, we needed them back in the 90s and 2000s, but as Richard had said, we've taken 2 steps backward. We need them more today because we need to prove the actual physiology, what's wrong with our patients when we come up with these genetic diagnoses. So I want to thank you for your mentorship. It all comes around. My daughter is working on a STEM project. She's 17 years old. She's actually taking some cardiomyocytes made from some of my patients with mitochondrial diseases. We turned them into stem cells and back into cardiomyocytes, and she's looking at lipid peroxidation levels and how maybe those can be altered by certain vitamins and or medications on the marketplace now. So, education, legacy, passing on the torch to people that are going to be smarter than us. And, the next 25 years will be great, and hopefully we'll be able to close down the shop because there really will be cures for mitochondrial disease. I'd like to also want to know the panelists' views on some of these new potential therapies like RNA therapy, somewhat advanced along by the RNA vaccines.
Thoughts on that?
Brian, would it be all right if I comment?
Please do.
Yeah. Well, thank you, Bruce. Of course, everybody in this committee and so many, many other people have dedicated their lives to these patients, and we really have made progress. I must say one of the great tragedies is the loss of Chuck Hoppel's phenomenal biochemical diagnostics program. And it does indicate, and I call out to our colleagues, the great risk we have of people becoming complacent, and so much of the resources that have been built so arduously are being lost. One of the things that Richard mentioned, and I will underscore strongly, there has come to be the idea that if you can sequence the DNA, the answer is there and there's nothing more to be done. And as a result, I'm seeing many NIH programs basically saying, well, if you don't use this one technique to answer that one question, then this is really not a fundable project. And this is, I think, a very serious setback because we really don't understand the biology of mitochondria. We have understanding of the basic basic biochemistry of oxidative phosphorylation, but we have nothing on our understanding of how it relates to hormones, to all the physiology of the body, to many, many complicated systems that are very, very important to our patients and real potential for therapeutic involvement. For instance, we're right now working on histamine and the role of histamine in regulating mitochondrial function. It's a new area that could be very important for treatment. And then beyond that, there is a great deal of interest in gene therapy, RNA therapy. Our group is putting a great deal of effort in that, along with Larry, in collaboration. But the other point I want to make is that the other thing that concerns me is the idea that we now know what mitochondrial disease is, and therefore, if we only work on those diseases, then that's what we need to do. But we've been very, very interested in autism, for instance, and schizophrenia. Just to make the point, the brain is only 2% of your body weight, but uses 20% of your energy. Hundreds of millions, if not billions of dollars have been spent on sequencing the nuclear genome of people with various neurological diseases. And we can only explain a few percent, maybe 20, at most 30% of the risk of these diseases. Yet to try and get anyone to consider looking at mitochondria, which Richard did years and years ago, and also Billy DeMauro, as a cause for this neurological problem of autism, it's impossible now. The NIH and the funding agencies just feel, well, just sequence more nuclear DNA. The mitochondrial DNA is almost completely ignored, for example. So we need to go forward with a much bigger vision that we have something to contribute to a wide range of important diseases, not only neurological and cardiac and renal and muscle, but also aging and diabetes and obesity. These are the really major problems that the standard nuclear paradigm is not solving. And I truly believe this organization needs to look forward to moving in that broader area, taking the therapies that we've so arduously developed, but then beginning to see how they could be applied to a much larger community and have a much greater impact. So thank you.
Thank you.
Yes. And I'd like to say that Doug eloquently stated my own thoughts as well. And so I thank him for it.
I'm sure the panel agrees, and certainly, Phil, I think about Dr. Wallace's comment here put a nice bow on this conversation today. There's so much for us to celebrate, right? There's so much for us to celebrate, so much to reflect on, but the reality is there's a lot of work to be done as well.
Absolutely. And one of the things to celebrate is that we have advisors to UMDF, like these gentlemen. We ask, they give us honest, candid answers, and we have to acknowledge that not everything is perfect yet. But I get really excited to hear when they call out areas where there needs to be more attention. That helps you and I begin to set the mission and the programs of UMDF to address those gaps. And we're so fortunate to have leaders like this be a part of the mitochondrial disease community.
Well, we are relentless in our pursuit in building this team. This panel of Vanguard Award winners is certainly leaders of that team. And we're counting on the community to continue to come together to move our mission forward. And I just wanted to extend my sincere gratitude to our Vanguard Award winners, Dr. Chuck Hopple, Dr. Doug Wallace, Dr. Richard Haas, Dr. Larry Grossman, Dr. Bruce Cohen, and Dr. Salvatore DeMauro for being part of that team and for helping us lead in this effort. We certainly cannot do it without you. And we cannot do it without our community at large, the patient families we serve, our clinicians, researchers, our generous donors. That is what has sustained the UMDF for 25 years, and it will continue to help move us forward with everything that we talked about today. And with everything that we talked about today, you want to make sure that you subscribe to our social media channels. Be sure to check out our YouTube channel to see all these great conversations that we have with leaders in the mitochondrial disease space. Once again, thank you to our Vanguard guests today for doing all that you do for the patient families we serve. Thanks, everyone.
Thank you very much.
Thank you for arranging this.